So today we're going to talk about theoretical and experimental probability, and to be honest, this is the math that you guys see all the time. Here's a spinner, the Mickey Mouse Clubhouse game, that my kids want to play every day, and it's all probability. So just look at the spinner. What do you think they get the most often? Alright, we will talk about that more in class, but hopefully you know it is that's right, it's the stars. Alright, so probability, alright, what are my chances? This is the likelihood that something's going to happen, and you can show it with fractions, decimals, or percents. You've probably already done experiments with this, with spinners, with dice, flipping a coin, or even picking cards. Now, theoretical probability is when all possible outcomes are equally likely to happen. What that means is you have a fair chance. Alright? So, flipping a coin, rolling a number on a dice, these are fair chances. Not unless it's a two-headed coin or it's dice where there's 2 3s on it or something like that. So, the probability of the event is the number of favorable outcomes over the number of possible outcomes. So now think about it. If I'm flipping a coin, what are my chances of getting heads? It's going to be 1 out of 2. One side is heads, and there's 2 possible sides. Same thing with rolling a dice. What are my chances of rolling a 4? Well, there's 1 4 on the dice, and how many total sides does it have with different numbers? 6. So my probability is 1 out of 6 of rolling a 4. Now, the complement of an event are all the outcomes that are not in the event. So basically, it's what is not going to happen. So if you have the probability, and then you have what's not going to happen, that equals 1. So let's just look at the dice example again. It's a 1 out of 6 chance that I'm going to roll a 4. What are the chances that I'm not going to roll a 4? Well, there's 5 other sides that don't have a 4 on it. So it's 5 out of 6. If you add that up, you can add fractions when the denominators are the same. It's going to be 6 out of 6, or 1. Alright, 1 whole. So think about it. Is it more likely that yes, I'll roll a 4, or I will not roll a 4? What's your guess? Hopefully you said not roll a 4. Now the other way you can look at this is what's the chances of it not happening? Take that 1 whole and subtract the probability of the event happening. What you have left is what wouldn't happen. Just 2 different ways to look at that formula. Now, odds. Let's be honest, when you're talking about odds, that's probably some type of betting or gambling going on. Right? You're trying to beat the odds to get money. So odds in favor, that's when you have the number of favorable outcomes over the number of unfavorable outcomes. This is different than probability. So I'm just going to stick with the dice example. The number of favorable outcomes, how many chances do I have to roll a 4? 1 chance over the unfavorable outcomes. This time it's not 6, this time it's 5, right? Because there's the numbers 1, 2, 3, 5, and 6. Those are 5 numbers where it's unfavorable. It is not the total this time. This is where it's a little bit different. And the odds against, you take the number of unfavorable outcomes over the number of favorable outcomes. Again, if I use that dice example, I've got 5 ways it might not happen over 1 way it could possibly happen. Again, the odds are against me rolling a 4. Now, experimental probability is exactly what it sounds. It's when you actually get to experiment. So it's based on the data you collect from repeated trials. So if you flip a coin, there's a 1 out of 2 chance that you're going to land on heads. It's a 50-50 shot. But if you've ever done this, it probably doesn't work out. Well, I got heads 50 times and tails 50 times. right? It doesn't work out like that every single time because it's an experiment. And what results you get, your partner might not get those same results. But this is the actual data, all right? The probability comes from, the numerator is the number of times the event occurs and over the number of times the experiment is done. So if you look at the data below, what was the experimental probability of heads? Well, this person flipped heads 7 times. And how many times was the experiment done? 12 times. If you work that out, that is not 50% like it should be, like it theoretically should be. It is pretty darn close, but it's still greater than. So the biggest difference, the theoretical probability is what should happen, and experimental probability is what actually happens after doing your experiment, after doing your trials. So we're going to take a look at this stuff tomorrow and do some experiments of our own. Okay? See you then.